Hello everybody, so Beaton here and welcome back to another past paper practice question. In this video, we will be looking at another number theory question. Let's not waste any more time, let's head straight into this question. So it says, the diagram below shows the first three shapes in a sequence, which forms a pattern. Each shape is made using a small set of white counters and black counters. So we have shape 1. Shape 1, we have 1 being shaded at the top, 3 being shaded at the bottom, and then we have 2 rows of white counters to follow with the same number of columns. And then we have for shape 2, we have 1 at the top, followed by 3, and then we have an additional 2 at the side, and then we have 3 rows to follow with the same numbers here. So for shape 3, we have 1 at the top, 2 extra black ones at the side, and then we have another 2 extra set of black counters at the side, and then we have another 2 set of black counters at the side. And then we have 1, 2, 3, 4 rows to follow. So that means for shape 4, so I'll draw shape 4 right to the side here. For shape 4, the pattern should continue. I'll have 1 at the top, so for the row previously, for the shape previously, I had 1, 2, 3, 4. 4 rows of black counters. So that means in this one, I'll have 5 rows. So of course, I'll shade out I'll put an extra black counter here. So now it's equal to the one that I had previously. So in this one, I had 1, 2, 3, 4, 5, 6, 7. I should have 7 here. 1, 2, 3, 4, 5, 6, 7. So now I have, it's the same as the one previously. So now for the shape 4, I'll add in an extra one. So I'll add in an extra row at the bottom here. So I'll draw the same amount that I have at the top. Then I add in the extra one. Then of course, I have 1, 2, 3, 4. Rows of white ones. So that means I'll have 5 rows of white one here. So I'll draw 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this will continue. So I just want to double check. So I should have 1, 2, 3, 4, 5. So 5 rows of white counters for shape 4. So this will be shape 4. And this is how you get all of your marks. Just look for the pattern and you draw to suit. So let's move on to the next question. So this one says, the number of white counters, W, the number of black counters, B, and the total number of counters, T, that form each shape follow a pattern. So the values for W, B, and T for the first 3 shapes are shown in the table below. Study the pattern of numbers in each row of the table and answer the questions that follow. So I have to complete rows 1, 2, and 3 in the table. And total this table is going for 2 marks. So this table looks like one of the easiest one that I will complete. So let's look at the pattern. So for shape number 1, I see we have formula being given here, which is 1 plus 1, then multiply 2 by 1 plus 1, and this will give me an answer of 6. And for shape number 2, I have 2 plus 1 again, and then I have in another bracket 2 multiplied by 2 plus 1. So as I already see that these numbers here are adjusting based on the shape number, so let's see that will continue. So for shape 3, I have 3 plus 1 again, 2 multiplied by 3. So I see is that the entire thing is changed. It's just this one in bracket here. So 2 multiplied by 3 and plus 1 again, and that will give me an answer. So here I have an answer for the 5, so I don't need to fill that. But they're asking me for a pattern here. So let's see what is going on. So I have 1 plus 1, and then I square that answer to get 4. Then I have for shape 2, I have 2 plus 1, and then I square it. For shape 3, I have 3 plus 1, and then I square it. So for shape 4, I should have 4 plus 1, and then I square that. So 4 plus 1 is 5. 5 squares would be 25. And that is as easy as that. So let's see what we do to get the number of counters, which is t. So here we have 10. We have 6 here, and we have 4 here. So we know 6 plus 4 would give us 10. Here we have 24. So we have 15 plus 9. That would give us 24. And then we have 44. So we know 28 plus 16. That would give us 44. So all we're doing to get the total number of counters, all we're doing, we're adding the number of black counters plus the number of white counters. So this will be 45 plus 25. That'll give us 70 here. As easy as that. So 70 is the answer. So this, we're seeing that they're asking us to put in this value here. So we know it's this value plus this value will give us 420. So if we want to get this value here, all we're doing, we're subtracting. We have 420, subtract 144, and that would give us 276. That answer there. And now we want to find this answer. So let's try to work backwards. And in order for us to work backwards, let's fill up at the bottom here, which will give us a general formula. So you know here would be n. So the formula to get this here, we know it's whatever value is here plus 1. So this would be n plus 1. I'll put that in a bracket. And then this will be multiplied by 2 multiplied by n, which would be 2n plus 1. And this will give us, so let's try to work this out. So I'll do the work on the side here. So n plus 1 multiplied by 2n plus 1. So this will give me, I'll take this for its value. This will be n multiplied by 2n plus 1. And I'll take plus 1 multiplied by 2n plus 1. So n times 2n would give me 2n squared. And n times 1 would give me plus n. And 1 multiplied throughout here, you will get the same answer, which is plus 2n plus 1. This will be 2n squared. N plus 2n will give me plus 3n plus 1. So this answer here would be 2n squared plus 3n plus 1. So it's just some algebra we had to use there. And then to get the number of black counters, we know it's whatever number here plus 1 squared. So this will be n plus 1 squared. Hence this will give me n plus 1 multiplied by n plus 1. So this will be, we take the first term, which is n, and we multiply by everything here. So this will be n plus 1, and then we take the plus 1 and we multiply by everything here again. So n plus 1. So n times n would give me n squared plus n times 1 would give me n plus, and we know this should be a 1 here. So plus 1 multiplied throughout will give us the same thing, which is n plus 1. So we now have n squared, and n plus n will give me plus 2n plus 1. So here would be n squared plus 2n plus 1. And of course, we need to add this and this, and we will get the same answer. Here, if you do that, if you do the math, you will get that. If you take the like terms and add, you see you'll get the same answer. N squared plus n squared will give us 3n squared. 3n plus 2n will give us 5n. And 1 plus 1 will give us 2. Now, back to this one here now. So back to this one. So we see we'll have, we need to do, see this line is worth 2 marks because, and you just have one thing to find because you have to do some amount of work here. So we see we'll use this formula to find for this number here. So we know the number that we want to find here would be n. So what we can do, so I work it at the top here. So we'll have 2n squared plus 3n plus 1, and that should be equal to 276. So we have a quadratic. So this will be simplified to 2n squared plus 3n. So this 176 is adding, or you take it over the subtract. So we'll have 1 subtract 276, which will give us a minus 275, and that is equal to 0. So what I can do now, I can factorize this and then solve. So what I will do, I will erase this to get some space. So what I will have now, so I'll use the AC method to factorize. So we know AC will be, A in this case would be 2 multiplied by C, so which is 2 multiplied by negative 275. And that would give me a negative 550. So I want two numbers. When I multiply them, I should get negative 550. When I add them, I should get 3. So you have to think of a number that has, think of two numbers that have a difference of 3 in between them. So I know when I see 550 and I see the 50, I know I should think of either a number that has like a number like 50 or a number like 25. So let's try 25. So what can I multiply by? Let's divide 550. Well, let's divide negative 550 by 25. So I will get 22. So what I can do, I can try a negative 22 multiplied by 25, and that would give me negative 550. And then I know negative 22 plus 25, that would give me the 3. So this is the important thing with the AC method, trying to find two numbers to substitute for 3n. So I found the two suitable numbers to be negative 22 plus 25. So now I'll have 2n squared minus 22n plus 25n minus 275, and that is equal to 0. So I can bracket these off and then factorize. So 2n squared minus 2n, I see the common factor there would be 2n. In bracket, I'll be left with n minus 11. Then I'll have, I see, plus 25n and 275. So I see the common factor here will be plus 25. And I'll be left with n minus 11, and that is equal to 0. So I'll have 2n plus 25 in one bracket, and n minus 11 in another bracket is equal to 0. So I can now solve. So I see 2n plus 25 is equal to 0. So here we'll have 2n is equal to negative 25. N will be equal to negative 25 divided by 2. And we know that will give us a negative something. We know that definitely can't work for this here because we're not dealing with any negative numbers. So let's try the other one, which is n minus 11 is equal to 0. So n will be equal to 11. So here we see the number is 11 because you know when you solve a quadratic, you'll have two answers. So we will just use a positive value in this case. So we can see why this question is worth 2 marks, because we had to use the knowledge of quadratic equations to answer this question. So that would be 11 for that answer, and you have all your marks as long as you do the work. So this one was a bit challenging, simple, but you just had to do some work in. You have to recall your knowledge of quadratics. So let's move on to the next question. The next question says, the expression for the total number of functors t equal w plus b in shape S is given by t is equal to as squared plus bs plus 2, where a and b are both positive integers. So by substituting suitable values for s, show that the total number of functors in shape 1 and shape 3 in terms of a and b is represented by the equations a plus b is equal to 8 and 3a plus b is equal to 14 respectively. So we see the formula that we're interested in. The formula they give us to arrive at these two would be t is equal to as squared plus bs plus 2. And they want us to show that the total number of functors in shape 1 and shape 3 is equal to these two respectively. So let's deal with shape 1. So we know This top one here is dealing with shape 1, since it said respectively. That's the first one. So for shape 1, we see the total number of contours would be 10. So that means this t here would be 10, and we need to find two suitable values for a and b. So they said by substituting suitable values for s, so we see for shape 1, the value of s is 1. So all we do is substitute 1 in the equation. And we know t is equal to 10. So this will be 10 is equal to a. So a suitable value. So to show that this here would be equal to this here that they want us to show. So we know t will be the total number of contours, which we found to be 10. So this will be 10 is equal to a multiplied by, so we see s. So we see s for shape 1 is equal to 1. So this will be a multiplied by 1 squared plus b multiplied by s, which is 1, plus 2. So 10 would be equal to 1 squared would be 1, so a times 1 would be a, plus b times 1 would be b, plus 2. Hence this will be, so we want to, this 2 is adding, we take the will subtract, so we'll have 10 subtract 2 is equal to a plus b. So 10 subtract 2 would be 8 is equal to a plus b. So we can simply rewrite this and say a plus b is equal to 8. And that is how we show for this one. And for the second one, we have 3a plus 14. So we're using the same equation, which is t is equal to a s squared plus bs plus 2. So we see for this one, we're dealing with shape 3. So for shape 3, we see t is equal to, so let's go to shape 3. For shape 3, we see t is equal to 4 to 4. And s is equal to 3. So t is equal to 4 to 4, s is equal to 3. So we'll substitute those values into this equation. So we see t is 44 is equal to a multiplied by s, which is 3. So this is 3 squared plus b multiplied by s, which is 3, plus 2. So we'll have 4 to 4 is equal to a multiplied by 3 3's 9 plus b multiplied by 3, which is 3b plus 2. So you know a times 9 would simply give me 9a. So I can simplify this further because I want it to look like this thing that they want me to show. So I can carry over the 2. So I'll have 4 to 4. 2 is added, we take it over, we'll subtract. Subtract 2 is equal to 9a plus 3b. So I have 4 to 4 subtract 2 would give me 42 is equal to 9a plus 3b. So I can rewrite this and say 9a plus 3b is equal to 42. But that does not look like the equation that we want. So we see all of these terms here are factors of 3. So what I can do, I can divide everything in this equation by 3. So 9a divided by 3 would give me 3a plus 3b divided by 3 would give me b. And this is equal to 42 divided by 3 would give me 14. Hence, this is my answer here for this question. And that is how I show that this here is equal to this. I just substitute suitable values. And these are the suitable values. I got these values from the table, and then I work it out. And with that, this has brought me to the end of this video. So we see we had to do some amount of work, but nevertheless, it was simple work. So remember to keep practicing. That is the only way you can master these questions. Keep practicing, and I'll see you in the next video where we look at some additional questions. Until then, take care and keep practicing.